in general, words are certainly not independent of each other, right? Words are correlated, but you can find words that are relatively independent of each other. So, and if you find them, you can actually do some neat things. So, if you have examples of independent words, you can, for example, estimate the index size of a certain search engine without knowing it. Now, that assumes that the search engine actually reports accurate counts of the results that it returns, which is sadly no longer the case. But it was true a couple of years ago, and I'll show you an example of estimating an index size for Bing. But let's talk about an example. So suppose we have this black box search engine. We'd like to figure out how many documents it has indexed, how many web pages. By the way, the index size, the number of indexed pages, it's actually a fairly closely, it's a secret. Search engines don't advertise it. The reason that they don't advertise it is there is a well-known correlation between the quality of results and the size of the index. At the very end of the course, we're actually going to show why exactly having a bigger index almost always leads to higher accuracy. We don't have the machinery to show it now, but just accept it as a fact, right? So as a search engine, you want everybody to believe that you have the biggest index that you have. So we have our search engine X. We'd like to know what is the index size of it. Now, of course, it doesn't tell us how many documents it has, but suppose that we found some words that we know should occur independently of each other, words A and B. Right? So what we're going to do is we're going to take these words and we're going to run 3 queries on the search engine. We're going to run the word A by itself, we're going to run the word B by itself, and then we're going to run the words A and B together. Now, most search engines treat a multi-word query as a conjunction. So if you type running aardvark, they look for documents that contain both the word running and the word aardvark. And the search engine will usually tell you how many results it has. It's an estimate, but it used to be a pretty accurate estimate. So let's say we observe n of A, that's the number of results that we have for query A, n of B is the number of results for query B, and n of A and B is the number of results for the query that had both words A and B in it. Now, we said that A and B are independent, so the definition of independence is the probability of observing A and B together should be the product of the marginals. The probability of observing A by itself times the probability of observing B by itself. That's the definition of independence. Now, what is probability of A and B together? It's the number of times that A and B occurred in the dataset divided by the total number of documents. That is our index size. That's what we're trying to find. Okay? And here I'm just substituting the definition of P of A and P of B. So number of times A occurred by itself, number of times B occurred by itself divided by the index size. Put all the numbers together, you get an estimate for n. Right? It's n of A times n of B divided by n of A and B occurring together. Now, so that should be the estimate for the index size. I guess there's a neat analogy to this so if you're trying to make sense of what this is doing, it's like answering the question how many fish there are in the ocean, right? You can't answer that question, but one thing you could do, and that is, it's a procedure that's actually used by marine biologists, is you sample the fish, right? You tag the ones that you have caught, then you release them, and then you sample again and see how many of the ones that you've tagged you get back. That's the analogy. It's called capture-recapture. So we're just doing it for text. So now in reality, words are so rare that that this estimate is going to be way off. But if you repeat it many different times with different independent pairs A, B, you should actually get a nice consensus going. You can also adjust this procedure. Actually, before I talk about that, let me give you an example of this in practice. Right? So I did this in 2011. Sadly, you can no longer do it because none of the major search engines report accurate estimates of the number of results. But in 2011, Bing did, and in 2010, Google did. but they've changed their practice. So I just picked words here. Now these are not independent. These are just the words that I came up with that I thought might be kind of independent. Right. So the word write and the word walk. Okay. Write occurred about 2 million web pages. Walk in about 600 million. Oh, sorry. Write was 2 billion. Right. And together they occurred in 328 million. So you plug the numbers in, you get 4.3 billion as the estimate of Bing's index size based on just these two words. And then I take the words green and John, so green is about 1 billion, John is about 1 billion, together they're 200 million, so the estimate of that is about 7 billion. Repeat it a few times over, and what you see is the individual frequencies of the words are very different, but the estimates that I'm getting are actually all in the same ballpark. They vary, but they don't vary by a factor of 10. Right? They're all pretty close to each other. So if you look at that, the inference that I make is, around 2011, Bing probably had an index of about 6 billion web pages. And that number is actually quite a bit lower than all the promotional material that search engines usually put out. And that's kind of an interesting observation. So now, what if you don't know if the words are independent or not? Coming up with independent words is hard. But if you had a sample of the search engine data, and you're assuming, of course, that this sample is random and representative of the web out there, then you could use this sample to guess the amount of correlation between the words A and B, and then use that correlation to adjust your estimates for the index size. So what it is basically you're saying, so if A and B were really independent of each other, so S of A and B is the frequency, how many times I get A and B together in the sample, and S is the total size of that sample. So if A and B were totally uncorrelated, then C wouldn't be here, and I would just have the same thing that I had there. N of A and B over N is N of A over N times N over B, and B over N. But if they're correlated, then I'm going to have a constant here. That constant tells me so if they're positively correlated, it'll be bigger than 1. So together they occur more often than you would expect by chance. If they're negatively correlated, C will be smaller than 1. So you can compute C from this formula, and then you can use C to adjust your estimate of the index size for N, which is the search engine that you're trying to estimate.